3.1 Inequalities and their graphs. An inequality is a math sentence that uses an inequality symbol such as a less than, a greater than, less than or equal to, or greater than or equal to compare the values of two expressions. When we write an inequality to represent the following, you'll be using those symbols. So for instance, we want to write one that says all real numbers x less than or equal to -7. Less than or equal to means that you would have to have a symbol that looks like this. And it says all real numbers x. Well, that would be all the numbers that we work with, so we're just going to give it a variable. Less than or equal to -7. So this says that x is going to be any number less than -7 or equal to it. This one says 6 less than a number x is greater than 13. Be careful because that less than thing, you still have to write it backwards. So x minus 6, okay, is greater than 13. Okay, less than a number x. All right, that means it has to come second. Finding solutions to inequalities. This is very important that you be able to understand how to do this. And again, this is plugging in and making sense of what you've got. The question says, is -3 a solution of this inequality? So what they're asking you to do is plug in right there for x and put in -3. So you're going to say 2 times -3 and use the parentheses where you plug in, plus 1, is that greater than -3? Well, 2 times a -3 is a -6. A -6 plus 1 makes a -5. Is -5 greater than -3? Remember, we're talking about on this end of the scale, your number line would be -3, and then -5. Is -5 greater than -3? No, it's going further away from 0. The numbers further away from 0 in the left direction are small. So this would be no. So that means that -3 is not a solution. Okay? So that's what you're going to do with these. Let me clean up some of my mess. Okay? All right, on this one, they're asking you, is -1 a solution to that same problem? Well, let's plug it in. Everywhere there's an x, we're going to plug in. So 2 times a -1 plus 1, is that greater than or -3? 2 times a -1 is -2. -2 plus 1 is -1. And on the number line, we have -1. We have a 0 in here somewhere. We have 3. We have -3 on this end. So -1. All right, so is -1 greater than -3? -1 is closer to 0, so yes, it is a solution. Okay, that's what they're asking you to do. So plug in for values that they give you. All right. When you're graphing, use an open circle like this to represent less than or greater than, and use a closed circle like this when you are doing less than or equal to or greater than or equal to. Okay? If the variable is on the left side, which is what we've been practicing on, now you're going to be able to use it. Make sure your variable is on your left side. You draw your arrow in the same direction as the inequality symbol. If the variable is on the right, you will draw it backwards, or use the symmetric property and flip it around. For example, like the one. For instance, if we had -1 less than x, and we wanted to flip that around so we could graph it, and we wanted the variable on the left, Then all you have to do is flip it around. Make sure that this mouth is going towards the x in that direction and then -1. This is the symmetric property. It says we can flip it around. But you want to have it over there so that way if you were drawing the line to this, that you would draw this direction and shade this way on your number line. Okay? Because the arrow is pointing that way. That's using the symmetric property. Okay. All right, now this one is a little bit more complex than what we'll be doing in the first section, but I think you're ready for this. We've been doing solving equations, so this should be no big deal. When you're doing these, you want to think of this inequality right here as your equal sign wall, okay? So you're just going to pretend that their wall goes through that sign. So you're going to do 2 times x, which is 2x, 2 times a -5, which is -10, -4 times x, which is -4x, and -4 times 1, which is -4. Because in order to solve, we found that we must get rid of the parentheses first by distributing. This is the distributive property. Okay? All right. Now, we're going to move the variables all to the left. So I'm going to add 4x to both sides. Okay? Now, we're going to, we've been doing it vertically, up and down, but you may also see that addition property written this way. 2x minus 10 plus 4x is greater than -4x minus 4 plus 4x. You see how they added that horizontally? This is also the addition property. A lot of times on testing, they will show it like this, so don't be confused that this is still adding this, so this is still the addition property because you add it to both sides, okay? Whether it's written horizontally or vertically, like we've been doing, it's still addition. You still add, so it's 2 plus 4 is 6, minus 10 greater than -4. Add your 10 to both sides. That's again addition property. You may see it written 6x minus 10 plus 10 is greater than -4 plus 10. Okay? This is again adding 10 to both sides, addition. Alright, so then when we are finished with this, we end up with -4 plus 10, which is 6, and 6x. So then we divide by 6, which is the division property, and we get x is greater than 1. Now we're going to graph it. Now because it is a greater than or less than without the line underneath it, we're going to have an open circle at 1. So it's an open circle at 1. And because we have our variable on the left, the symbol is x is greater than. I want you to say it when you're doing this. Greater than 1. Which side of the arrow is greater than on? It's this direction, the same way that this is pointing. Okay? So we would shade all of these and the arrow because it includes all these numbers. So on and on and on forever towards the right. Now there's a couple of notations we need to talk about. Set builder notation and interval notation. Set builder notation has a set bracket. That's how you're going to know the difference. And whatever variable they give you in your problem, you'll say that variable such that that variable. Whatever variable, whether it could be A, C, doesn't matter. Whatever letter they give you. And you're just going to write this part next. Greater than 1. And then the brace. That's for the set. That's set builder. And it's read x such that x is greater than 1. Okay, so the way to tell the difference, set builder sets have braces. Okay, when you're writing interval notation, that's a little bit different. Okay, when you're looking at this, this should have been not this. This is incorrect. When you're doing interval notation, you're talking about where you start, you're going this way, and you're talking about a parenthesis. Because it does not include it, you use a parenthesis. If it did include it, then it would have a bracket. disregard this right here. Alright, sorry, I saw that mistake. Disregard that. Alright, so because we're starting at 1, you're going to have a parenthesis, and you'll put the number 1. And you'll put a comma. And then you're going to go on and on forever in this direction. That's going towards positive infinity. And this is the symbol for infinity. In case you didn't know. Okay? Now, on this end of the arrow is the negative infinity. So if it was going this direction, then it would be going towards negative infinity. We don't have any of those numbers. We only have from 1, which is not included because it's an open circle, to positive infinity. And that would be your interval notation. Okay? So it's just from 1 to positive infinity. Now, if it had a line under there and say was x is greater than or equal to 1, then instead of a parenthesis, there would be a bracket. Okay? So this is interval notation. This is set builder. And we'll practice on this. It is pretty new for you. Right? Next page. Let's do some practice. On this one, it says x is greater than negative 4. So that's going to be an open circle at negative 4. And it is greater than, so that would mean it would go in this direction because our variable's on the left. We would draw it in the same direction. And when x is greater than negative 4, that would be all these numbers bigger than negative 4. Now, we're going to write each one of these in set builder and interval notation, okay? So this one, interval notation, is really easy. Remember, we use a parenthesis if it's not included. We write negative 4, because that's where it starts, and it goes on and on and on in the positive direction. So that is our interval notation. We'll call it I. Okay? Now let's do it in set builder. Set builder is going to have the variable in braces x such that x, and you just write greater than negative 4. There we go. This is set builder. Okay, we're going to do that for each one of our problems. All right, so the next one says x is less than or equal to 6. So we're going to find 6 on the number line and color it in because it is equal to this. We have a line underneath it. There is a closed circle. Because if x is on the left, we draw the arrow that way. And it also says x is less than, so that means all the numbers less than 6. Okay? So we're going that direction. If we're doing our interval notation, okay, this is going towards negative infinity. Now, because we read these left to right, we have to put the negative infinity first. Okay, we read it left to right, and that goes all the way up to 6. And because it includes it, it will be a bracket. To put it in set builder notation, it's going to be the brace x such that x is less than or equal to 6. Okay? That's the next problem. Notice how my x is on the wrong side. I'm going to use the symmetric property and flip it around. Symmetric property. So that would be x less than equal to negative 1 because I have to have the symbol look exactly the same as when I flip it around. It's pointing to the x, got to be pointing to the x here. Alright, so now I go to negative 1 and put a closed circle. And it says x is less than that, so I'm going to okay, in interval notation, that would be towards negative infinity to 1, negative 1 and bracket. And in set builder notation, that would be brace x such that x is less than or equal to -1. Okay? And the next one, we'll flip that around with this property. So that'll be x, and it's going to be greater, because the greater part's going towards the x, and a. Because it has a greater than, it's an open circle at 8, and it is greater than 8, in this way, so our IN would be, starting at 8, but not included, is going to positive infinity. Our SDN would be x such that x is greater than 8. Okay? And a couple important words that you want to memorize or just at least get familiar with. The greater than symbol also is known as more than. So if you hear a problem, they're talking about more than this or whatever, that's a key to this symbol. Less than, they would use fewer than or not as many, both of these. Greater than or equal to is no fewer than, at least, or no less than. These they like to use a lot. Less than or equal to, no more than, at most, at greatest. Very important. These are the two they like to use a lot. So please be familiar with them and try to make sense of what it is. Greater than goes with the first group. Less than goes with the second group. And then the not equal to sign is not the same. Okay, so know those vocab, because you'll be getting word problems where you have to set up inequalities, and you're going to be given words such as these, and you need to know which symbol to use. Okay? So if you have questions, come see me at school, and we'll work on these together. See you in class.